right. Good evening, everyone. Welcome to joining the public lecture organized by our faculty. And in the coming 45 to 50 minutes, we are going to study one of the very common health problems in our societies nowadays, which is about the overweight problems. So we will focus in 4 areas to see that the problems is really affecting our society as well as the personal perspective. We will see that any data to support that, are we all really getting better? Or then if so, what is the major causes that causes obesity in our in the human body? And then we will see some mechanisms to see that our body, how we would deal with the food intake. What happens if we overeat, or are we really needed to overeat? And at the end, we will see that any possible methods nowadays to treat the obesity, and what are the next steps to develop the anti-obesity method. Right, before we started the lecture, I would like to do a small survey. And please take out your mobile phone and scan this QR code, or go to the menti.com and input this code and tell me, what do you think about your body weight? All right. So you can see in here is that not many of you will think that you are overweight or obese. We have around 9 people think that we are overweight on that. So about 9 over 40 is about 20% thinks that you are overweight, and a lot of them thinks that it is the normal the body weight is normal. But is it really the case? Suppose in a statistical analysis or the modeling, the people here, what you think about your body weight should be reflected by a larger scale of the survey. And actually, the Hong Kong government have done this kind of a survey a few years ago, and around 60% of the people thinks that their body weight are normal. But if we examine their physical parameters and then using a more scientific way to evaluate whether you are obesity, the data are completely different. To determine whether you are obese or not, we cannot simply use a personal impressions or just like looking from the outside or outfit to tell you are obese or not. We will use a more scientific way to determine whether you are overweight or obese. And one of the common methods to determine whether your body weight is normal or not is the body mass index, BMI. This is a concept developed more than 100 years ago in around 1830, developed by a scientist in Belgium, a mathematician. He proposed that our body, if we wanted to see that whether we're overweight or not, we should use your weight in kilograms divided by the height and also the meter square of it. So by determining this number, we can classify the people. If normal, the number around 18 to 25, then you are normal. If you have more than 25 below the 30, you are overweight. And if you have a BMI more than 30, then you are obese. And this is a common method nowadays using around worldwide to do that. But in Asia, we have our own standard to do that. Because when you compare the people in the same BMI, Asian people will have more fat content than that of the Caucasian. This is why if you take a look at the government information, then you see that the criteria to determine whether you're overweight is a little bit lower than that using in the Western countries. In the Asian, in Hong Kong, if your body mass index is around 23 to 25, then you're already overweight. And then if you are over than that, you are obese. So if we take a look at this BMI level in the Hong Kong people, this is the average BMI of the Hong Kong people from 1970s to 2015. You will see that this number is keep increasing. And around the 1990s, then the average BMI of the Hong Kong people was already past the line of the overweight. And now in the latest data that published last year by the Public Health Survey, you see that the number of the people overweight together with the obese is more than half already. Much, much more than you think in the general idea of this. And this idea, increasing amount of the obese people, is not unique to Hong Kong. It's actually happening everywhere on the world. If you take a look at this data, this is the prevalence of the obesity. You can simply take it as a kind of number of people that are obese more than the BMI of 30. You see that no matter you are in the Europe, Africa, in the America, or everywhere of the world, you see that there is an increasing trend of it, both men and women. And in the number of that, in the 1980s, we have a 500 million, and today we already have a 631 million people that are obese. All right, if you are obese, then so what? If it doesn't cause us any problem at all, then it's not a problem. But indeed, obese actually causes at least 3 aspects affecting our daily life. One is the self-esteem. This is a very interesting study performed in 2016, a large-scale study that surveyed more than 2,000 people in Finland and asking them, what do you think about the overweight and your self-image? And the negative value means that you will have a negative impact on yourself. That means you lose confidence, you are not like to contact with others, a lot of different side effects of this. You will see that very interesting in the female, the women. They are more concerned about their body weight. They have negative impact if they have overweight, and then this significance more and more is becoming more and more serious as they getting older. That's middle 42 years. But in the men, this is very interesting that they don't care about the overweight. You see in here, before the 32, the mid-adulthood, they even think that getting obese is a better image for themselves because they link it with the muscle growth rather than the fat. But when they turn into 48, suddenly change the idea. They think that when they're getting fat, heavier, it's negative effect on this. So overall, this one, as you're getting fatter because of the social impact, you will have negative impact about yourself, causes the problem psychologically. And this overweight problem also affects your personal health, even to the economy of our society. If you compare the chance, the BMI, this is the BMI, and this is the chance that you develop the disease. And no matter you are talking about the diabetes right here, talking about the cardiovascular disease, means the heart problems, or talking about the liver disease, fatty liver, you all see that there is a positive correlation with your body BMI and the chance you get in this disease. That means the heavier you are, the more likely you will get this kind of a disease. And overall, if you are overweight, the chance you develop the diabetes is 5 times more than the normal people. And the heart disease is 2 times more than that. So that means if we have more and more people that are obese in our society, then the chance they develop different types of the disease will be higher. And then we need more money to treat this kind of disease. And indeed, this is the case in here. If we take a look at the data from the 1998 to 2002, you will see that the money that we spend on treating the disease related to the obesity is increasing from 2 billion to 3 billion already. So this contributes about 16% to 90%, causing more and more problem for this. So a very common idea is that why, if we are obese, why we are linked to this kind of a disease together. Using a type 2 diabetes as an example. So because the type 2 diabetes, the high blood glucose level, the patients with that, it is the strongest risk factor for this kind of disease. That means that if you compare the chance that you develop this type 2 diabetes, the obesity is the highest, the chance to get it. And indeed, more than 80% of this diabetes patients, they are obese persons, they are obese people. A simple idea how this fat will cause the diabetes is that when you overeat or whatever means it is, you take in a lot of food, this fat will store in the fat tissues. And they have limits. They cannot grow unlimited to a very, very big size. As long as they cannot hold the fats you eat, then this fat will spill over, and then they will accumulate in different types of tissues, for example, in the muscle. And these accumulations of the fat in the muscle will affect or change or reduce their ability to absorb the glucose from your blood in that. That means if you have more fat, they cannot get in the blood, the glucose, and so all the glucose will be remained in your blood, causing high blood glucose level. And then eventually you will develop diabetes. Because of this increasing number of the people with the obesity and the more and more money we need to spend on them, the Hong Kong government already know this kind of a problems. Sorry for this, don't know why I'm figuring this. So in the 2018, the Hong Kong government published a document called Towards 2025. It's about their visions, how to prevent the further development of the obesity in our populations. They set multiple goals, 9 in here, that should deal with different types of the health problems. One of them is treating the diabetes and obesity. They try to develop different kinds of methods, educations, promotions, working together with the healthcare, the family doctors. So as a way, they hoped that not to increase the number. This is too big for them. They just want to stop the growing of the number of the people getting more and more obese in that. They hope that they can achieve the goal in 2025, and then we'll see it to next year to see that whether we can get this done. All right, so we know that a lot of people are getting fatter and fatter, but why? The reason is why we were getting on that. So this is quite a difficult questions to answer because we can have multiple parameters that can change your body weight. So a lot of people knows that if you take the high calorie food, which is a very common nowadays, for example, in the soft drinks in here, this is the amount of the sugar for each particular soft drink in that. If you drink a can of Coke, you're actually taking more than 30 grams of sugar with that. If you take it every day, then you have a lot of the high calorie intake in your body. And so eventually you can get in fat. If you don't like to do the exercise, just wanted to stay at home watching Netflix, watching the Disney, then eventually and keep drinking the soft drinks like this, develop obesity. This is a very common way in that. But some people, they have a medical issues that will cause they have a higher body weight in that. For example, in the endocrinology's problem. This is a patient suffering a disease called the Cushing disease, which they have a high level of stress hormone in their body. In that way, they will affect their fat metabolism, and you will see that they will develop a big belly full of fat like this. And some people taking the drugs, particularly a kind of the antibiotics, then they will also getting their body weight increase easier than the normal people. And most people will think that genetics is a very important cause for the obesity development because they think that some people will develop obesity easier than the others. Then why? If everything's comparable, then the genes is the only reason that to explain that they are high, their obesity prompt phenotype of this. And somehow, if you read the news, you will read that sometimes they will report it like this. Scientists discover the key genes that make people fat. And it is true, if we change the functions of some genes, the people or experimental animals in the laboratory, they will develop obesity easier than that. For example, here. So in the laboratory setting, if we want to see whether a gene is really can cause obesity, the simplest way to do it is to remove it from your body. So we develop a technology called the knockout mice technology. It means that we cut the genes of interest from the DNA of that organism and then measure their body weight and different time, then we can do it. Simple. This is a simple idea. But the process is very, very complex in this way. we needed to take out the embryonic stem cell, then cut using some genetic method to cut the DNA and put it back to the animal. And this animal will, this embryo will develop and get the mice, and then we do more and more procedure, and eventually we get the knockout mice. Yeah. And these are the two examples developed by our research team, in telling you that some genes, actually, if you delete it, your body can develop obesity easier than normal. But we do have the protective genes as well. This is an example. So when this is the red square or circle is the knockout mice. If we put this knockout mice with the normal food, you see that their body weight is already different. They are heavier. But if we put them into the high fatty food like this, you see that the body weight is even more greatly different than that. And we can tell in here, if you lock out the gene, the animals can develop obesity easier than the control, the normal mice. On the other way, another example that we deleted another genes, that if we put the animals with the high-fat diet, they will see that getting fat. But if we lock out this gene, you see that they didn't change the body weight at all. So that means that all the genes in our body can both either is a good or bad to the development of obesity, depends on that. And at the end, if we do this experiment and also do some kinds of predictions, we know that around 6,000 of genes in your body can actually affect the body weight of it. And some of this can be proved in the humans. So at least more than 100 of genes are already related to the obesity development. But humans are not the animals in the laboratory. You cannot get rid of their genes and then to see that whether it will cause obesity. So we can only do is to compare their gene sequence. So we take out some blood from this different types of the people, normal, overweight, or obese, and then sequence their DNA, and then map the difference together with their body weight. And at the end, doing some kinds of mathematics and the statistical comparison, we know that some genes actually can cause the problem. And this is how we isolate more than 130 of this. Give you an example. This is the gene that already found to have the number, affecting the body weight. You see that if you have a mutation of some of this gene, the most famous one, FTO, you can have a great change for this BMI, this one. So very significant level on this. And in addition to this DNA sequencing method, we can also get the information from the patients. For example, if we have some patients that one gene is mutated, then we know that it's related to the obesity. An example showing here. This is a patient, Japanese lady, in that she has a mutation in one of the protein called the melanocortin 4 receptor, MC4R. This is a protein that can be found in your brain, in the cells, in the neurons. And if the functions of this protein is to control your food intake, if you activate it, then you don't want to eat. So the patient, this lady, has some mutations on this kind of the receptor, and so she will always feel hungry. And so this is why she keep eating. And you can tell from the 2 years old, she's already fatter than the normal 3 years old, and 23 years old, she gets a weight about more than 100 kilograms. That's very severe effect of the obesity. And this MC4R is the most common cause of the gene mutations in the human, causes the obesity. But we said it most common doesn't mean that the number of obese, or a not big number of the obese people because of these mutations. It just counts for 6% of the obese people that you found they have mutations of this. That means that majority of the people, they will have mutations. It's a kind of a combinatory effect of multiple genes. If you have the variations of the genes listed in here, together with unhealthy eating habits, eating a lot of food, then your chance to develop obesity is much, much higher. But if you have a normal diet, even though you have this kind of the gene mutations, most likely you will not develop obesity. It depends on the combinations of all the factors that add together causes the problem. All right. So if the eating will cause obesity, then we will stop eating, right? When we feel full, then you stop eating. Suppose if everything's normal, then you will not overeat. So just like this cat in here, get food, will not eat. But what happens when you finish a dinner and someone gives you an ice cream? What do you think about it? You will take it or not? Most likely you will take it. And then it will cause a problem of the more than you need, eat more than you need, the problem. And this is the most famous idea of the dessert stomach. That's always tells you that especially the ladies always tell me that I have another stomach that only reserved for the dessert. But is that true for that case, or just a kind of the excuse of overeat? Take a look at this experiment. Okay, this is an experiment done in the rat, and we fed the rat first so that it ate a lot of food already, and then put it in the maze and let them choose whether you will go to one arm that contains normal food or the other arm is the chocolate M&M. Really, they're using the M&M to do the experiment. Then they found that the rat will prefer to go to the M&Ms, to always go to there, but not into the normal food. So telling you that it's true, they like the dessert. Okay. Even more is that if we give the arm in here some kinds of electric shock, every time you get the M&Ms, you give a shock, but in here, no shock happens to there. You see in this graph, this is the amplitude of the shock. The number means that the higher, giving you higher intensity of the shock in that. So the animals will still go there, even though they get shocked every time from that. And some proportions of the rat, you see in here, they will never stop. And then even though you increase it to a very intolerable level, they will still go there, take the M&Ms. That's true. We do have the second stomach in our body. But why is that? So this time, the scientists use a human to do this experiment, not giving them salt, not actually that. They give them a milkshake and then put this subject into the functional magnetic resonance imaging, functional MRI. So this is a device like this. You just lay on here, the bed right here, and then in the meantime, you give you a drink that, and we measure the activities of your brain. And you can see in here, this is the result, telling the color one means that the area of the brain which is activated when you drink the milkshake right here, compared with the control drinking the water. Okay, you see that multiple area of this is activated, telling you that when you eat the dessert, something we call this one the palatable food, and then a lot of the area in your brain is activated. And what next activated for this? And they do more experiment, and eventually they found that in the time there is a special chemical. It's called the dopamine. In some of this region, you see that after you take in the milkshake in here, the level of dopamine in this region shoots up. And it is this dopamine that will cause different behavior to our body. You will motivate yourself to seeking more dessert, the milkshakes, and then they will also give you a reward sensation as well as giving you a reinforcement experience. In a simple way, it makes you happy when you're eating this kind of dessert things. So by doing more and more experiments, we know that the food intake behavior in our body is very, very complex. It is not as simple as using a single organ to control all like this. Rather, it involves a lot of the brain area. So they work together and then will cause us whether you want to eat. For example, when you feel hungry in the mouth, a part of your brain at the bottom of it, we call this one a hypothalamus. In the part of the neurons in the hypothalamus will be activated. And then they will send a signal to different parts of the brain. And now the animals will start to seek the food. And once you get the food, the more the regions of the brain is activated. And then this kind of work together, they will give you a happy sensations. So you can keep eating. But when you eat a lot of food, you feel full, and all the sets of the neurons will be activated and then telling you, okay, you just need to stop. Then this kind of might stop and go to sleep. So very happily do that. So based on this, so we know that the brain is very important, but another questions come after knowing this. Why our brain can sense that we have finished the meal, the drinks like this? We needed to have some other signals coming from the different parts of your body telling that, okay, you already get enough of food. Some of this are coming from the sugar. When you eat, then you increase the blood sugar, causes the activations of this neuron. And some of this will causes by the fats, and some of this will caused by the hormone kind of substance that produced by different parts of your brain, the different parts of your body to call this. I give you an example. What happens if we have problems in generating this kind of signals from our body? The very famous example of this is a hormone. You can simply take it as a kind of protein called the leptin. This is the protein found in around 1994. In that case, this is the first evidence that if we change the protein, the level, mutations causing it, then you will cause the problem of overeat and obesity. So in simply speaking, if you take in the food, then your fat cell will generate this kind of hormone. And this hormone will then get into your brain and ask it to stop eating. That's enough for this. If you have a mutations of this gene, it's not working, then you will develop obesity in mice like this, or in the human. This is a patient that have a mutations of the leptin, and you can see that they have a lot of fat accumulations in the body, and the 10 months is a 19 kilogram, double the size of the normal baby of this. So we know that the eating complicated. We are go at very a lot of people getting more and more fat, and then what is the available method to reduce it? Because if you're getting fat, then you will develop disease. What are the methods nowadays that we can use to treat this kind of problems? Okay, suppose you have a problem of your body weight. Usually you will seek the opinion from the doctor. The doctor will then to get a lot of assessment, and they will give you advice what you should do. The first thing they will ask you to do, most likely, is change your life habits. Ask you to do more exercise, or to change the food intake the pattern. For example, they will design special types of diet, reduce the amount of energy intake, and then at the end, you will try to reduce your body weight. But if it fails, most likely it failed, because a human, sorry to say that, we are lazy animals. So we don't want to exercise so hard, and we like to eat because it's happy. So eventually, we cannot lose our body weight. So what do to next is that drugs, give them the drugs to do that. So eat some drugs and then trying to help you to reduce the weight. Nowadays, we have two common methods to reduce your body weight through this kind of medications. First one is to reduce your absorption of fat. For example, this orlistat is a kind of an inhibitor. When we take in the food, okay, we have a lot of fat like this. We needed to absorb it. Before that, we needed to break it down into small molecules. And this breakdown process is by an enzyme called the lipase. And orlistat is a kind of a blocker blocking this enzyme, so that you eat the fat into that, you cannot break it down, and so you will not absorb it, and all the fat will expel out together with your poo-poo like this. Another way to stop this kind of the body weight growth, to suppress your food eating desire. It makes you don't want to eat, then everything's solved. Cusamere is a kind of very common product. They use two kinds of chemical, phentermine as well as topiramide. These are kind of small molecules acting on your brain. Okay, remember our brain is the center to control your food intake. They will act on your brain and different center, and then to stop your eating behavior. Sounds very perfect way to do it, right? That, but remember again, back to the case is our feeding control in the brain. A lot of mechanism is not clear. Okay, we know that some chemicals can do it, but these chemicals are not very specific. They will act on multiple areas of your brain and eventually causing some kinds of side effects, depressions, anxiety, a lot of the problems on the expected way. This is why we still don't have a perfect way to treat obesity. And the search for the obesity drugs is actually started more than 100 years ago. In here, this is the graph chart about the history of the FDA in America to prove the anti-obesity medications. You will see that we have many drugs that are approved and put into the market to do it. For example, in here, the DNP is already in 1933, which is trying to expand your increase of energy expenditure. We have the hormones, the Wimble pills, and we have the sabitramide, which is a kind of the suppressing your food intake, the chemicals of that. So a lot of choice, right? But take a look here. This is the withdrawal drugs from that. Some of the drugs, DNP, you see that they're put into the market in 1933, but it withdrew in 1938. And some of the drugs, 81, 89. And this very famous one, sabitramide, approved in 1997, withdraw 2010. Because all these drugs have a lot of side effects. Again, telling you this is that the causes the heart problem, depression, some kind of mouth drive, a lot of problems. And eventually, people taking the drugs, they have higher chance to die before they become obese. So this is why when the searching for the new medications for the anti-obesity is still a very hit topic in the scientific field. Right? If that's the case, what else we can do for that if these two methods has a problem? Remember a basic principle when you try to develop anti-obesity, whatever methods you want to use, is the energy balance. If we wanted to maintain our body weight in a normal level, you have to consider the amount of the energy intake from the food and the amount of the energy output for doing exercise. If the energy input is equal to the output, you will not change the body weight, maintain steady. However, if you overeat, like this case, you have more energy in, but less energy out, then you will develop obesity. And all the drugs nowadays we have is targeting on this input, energy input. For example, this Cruzumir, the Orlistat, they are trying to reduce your fat uptake and suppress your food intake, in this case. And the other way, if we have more energy output doing more exercise, and then have the remaining the same, the fat, even though we remain the same of the fat, the food intake, then your body weight will also drop. But any drugs that we can target this kind of an energy expenditure level of it. So far, we do not have any approved drugs for this purpose. But very interesting. Last year, we have an example to tell you that indeed we have some hope on this. But before we talk about it, then we will introduce you a little bit more about how our body will expand the energy to do that. If you take in the food, then you will break it down and generate the energy. Some energy they will use in the basic metabolic ways. This means that to maintain your body function, that basic chemistry reactions maintaining for that. You cannot change this part, otherwise you will die. Some of the energy they will then use for doing, we call doing work. For example, in the exercise or moving something, writing, or even the walking, then you will see that using that, which call this one activity-related one. Doing exercise, and this way increasing this part of the energy expenditure. Very interesting, some parts of the energy, we use it for the food digestions, a chemical reaction, then you need to spend energy for that. But we do have a part of the energy expenditure. Not everybody will recognize it. It's about the thermogenesis, means that it's your temperature control in your body. Take a look at this thermal imaging. Okay, this is a human. So we put into the thermal camera, and when this is normal conditions, in a very comfortable environment, if we put this guy into a cold room, okay, reduce the temperature, you see that the difference, that some area within the shoulder right here, or some area along your spinal cord, your backbone right here, is highly activated. And this thermal camera means that they are generating heat over here. So what are these tissues of that? They are fat. They are fat. But this fat is different from what most people think about it. That's when we talk about the fat, most people think that these are kind of the slippery, fatty stuff under your skin. So this is what we call the white fat. That's true. This is the major fat tissues in our body. But we do have a very unique fat in our body. We call this one the brown fat, because the color is really brown. You can see in here. This is the anatomy of the human. This is the neck and the shoulder. You have a piece of the tissues right here, the brown tissues, and you have a special cell type. This is the white fat cell, like this, a lot of fat. But here you have another one which containing a different structure than that. And the major functions of this brown fat is to generate heat. That when you put into a cold environment, this brown fat is activated, and you generate the heat. And you generate heat, you need energy to do that. Your energy in your body coming from the food you intake. That means that you will burn out more food and body reserve to support your body temperature change. If this kind of a fat is important for your energy expenditure, then very logical thinking is that we activate it, then we can have more temperature increase and more energy expenditure, right? In that case. But again, like what I said, we do not have any reagents that can do that before last year, because in the last year, the paper published in a research finding is that very interesting. They found a drug called the salbutamol in here. This is a drug used for treating the asthma. You get the problem with your breathing, and you intake this drug, your muscle in your airway will be released, and then you can breathe more smoothly. That when we give this drug to inject it into the body of the human, you see that the brown fat right here, when you compare with the control, this is the PET scanning, and the lighter the color means that it's activated. See that this is activated when you inject a single dose of it. And if we measure the energy expenditure, you see in here, this is the control, then there is an increase of the energy expenditure for that. And at the end, you see that you have fat mass reductions. Although this is not a very, very large one, it's about a few percent. But remember, this is just a single dose injections. In just one time, then you can have all these effects together. What if we inject it for a longer time? And can we reduce the body weight on that? And sadly, this study has not yet performed this experiment. So we are waiting to see that if we inject it for long term, whether we can change the body weight. So our research team is also interested in develop a way to reduce the body weight. But our target is different from the market. We are looking for something happen in the skeletal muscle, because skeletal muscle is the largest tissue in our body in terms of weight. So if we increase the energy expenditure for a little bit because of the large size, so the overall effect will be very, very promising. And after about more than 10 years research, we found the chemicals, 7,8-DHF and small chemical that you can find in the plant, naturally existing, some kinds of a daisy like this. You can extract it. And if we put these chemicals and feed the animals, we have not yet done any experiment in the humans yet. So if we feed the animal, you can see that this is the blue line is the one we're taking the 7,8-DHF. You see that the energy expenditure is more increased like that. This is a daytime, this is the daytime, this is a nighttime. We measure the energy expenditure of the animal in different day and different time. See that they're increasing more energy expenditure. And so after taking this for around 3 months, you can see that body weight, this is the control mice taking the high-fat diet, the fatty stuff. You see that taking the drugs in here, 7-8 dishes, they have a much reductions in the body weight. And this one is pretty promising, about 15 and 20%, because if you compare with the available drugs in the market, they just give you around 5 to 15% of drug, the body weight reduction. And our drugs is a very, very promising effect. And so we are very excited to find in this finding, and we hope that we can do more experiment in the human. And so one day we can put it into the market, and so everyone will be benefit. All right, but taking drugs is not always the best choice for the people. They always like to see if we do have other methods, not taking the pills, and then reduce the body weight. And is there any way that we can do that in not talking about the exercise? We do have some kinds of a method to do that. In the 2021, 3 years ago, so a group of scientists in New Zealand, they claim that they have invented the first ever anti-obesity device. That the idea is very, very simple. They put 2 pieces of the magnet on your teeth over right here. And so this magnet will stick together. And every time when you want to move your jaw, open your mouth, or stop chewing, you will have a very strong resistance that you don't want it to move anymore. And then this is a simple idea. You cannot move your jaw, you don't want to eat. That's it. Then you can see this is why the patients taking this device in 2 weeks, they lost 6 kilograms. Very, very promising effect, right? And that's effective as well. But a lot of problem also caused by this. Because you see, this is the pitching side, the selling to the market. But actually in the case is that you needed to put a lot of this magnet in your mouth to cause the resistance. And this magnet will also cause a problem of hygiene. You cannot open it, and so you cannot brush your teeth. Causes the breath bath, a lot of problems with that. So not a good way, very uncomfortable. But any other things more comfortable, one button for all. That means that any device that you kick one button, then you don't want to eat. Solve problem, everything. Technically, it's possible. It's possible to do that. Around 10 years ago, we developed the technologies called the optogenetic. Opto means to use light. Genetics means that it's a kind of the changing the genetic materials in that. So this is an experiment done in the mouse and rat as well. So we first change the cells within the brain. Putting down will have some kinds of the protein that is sensitive to light. Okay, you have this protein in the brain, and then we connect a kind of the optic fiber to that. And when you feel the light, turn the light on, then you will activate this kind of protein, and so your brain cells will be activated. Remember, the brain eating behavior all about your brain. That if you can activate the cells right here, then you can control your feed eating, the eating behavior. That's not sure if this is not working. But anyway, it doesn't work, so I cannot, sorry to that, I cannot show you the video. There is a video in the internet. If you type in the optogenetics food intake, you can find that. When you turn on the light, the animals will somehow start eating, even though it's already very, very full. If that, then you can control the eating behavior of it. But the other way around, if you can activate some kind of neuron that can stop eating when you turn the light on, then you can control your brain, the feeding behavior, right? Perfect idea to do that. But a drawback of this is that the area in our brain to control the food intake is very, very deep inside the brain. The mouse, you can do this, but in the human, you cannot put a light into your deep brain to start this one. Still very, very not, at least at this stage, it's not feasible at all. So what else can we do? So we don't want to do exercise. We want to eat. So the only things that we can do is to change your eating pattern. Yes. Perhaps you have heard about this kind of a method, 16-8 kind of the eating pattern. Scientifically, we call this one time-restricted feeding. Yes. That means that you restricted the time of the eating every day. For example, I wanted to eat only in the morning, and then we stop eating for the rest of the time. Like this, we started eating the 9 a.m. and then till 5 p.m. of the day, you can eat whatever you like. But after 5 p.m. of the day, then you have to stop eating. Nothing you can take except water, and that's it. And using this kind of method, a lot of people believe that it is working. You can reduce your body weight. I guess any of you might have tried this before or some of this. But is it really working? Any scientific evidence to prove that? Let's take a look at this experiment. Very interesting that we have been performed more than 10 years ago. We started at the time, this idea, the time-restricted feeding started to pop out, and the scientists immediately do experiment to prove it whether it was working or not. So they do a different set of experiments. The first set is that we use some fat mice in here, and then a group of mice, let them eat. You eat whatever, everything you can eat. And the other thing, and the other group is that we restricted that the food will only given to the mice in a particular period of time. Then you will see in here, this is the control group, FAA. In here, you can eat whatever the body weight grow. This is the time that we put this line means the time we restricted their feeding at a particular time. You see that grow eating, but once you restricted the time feeding right here, so the body weight drop, very, very significant, more than 20% of it, effective. How about the case is we do experiment in some normal mice before they get obese. Okay? Suppose you are normal body weight, and then you started to eat the fatty food, stuff like this. And at the meantime, you do a time-restricted feeding. Whatever 9 hours or 12 hours per day, you do this feeding. Take a look at this experiment, the result. This is the control right here. And if you restricted the time to 9 hours, you see body weight drops. Also effective together in the normal mice. What if we wanted to have some holidays? Okay, we only do this in a few days a week, and then the other days we feed it whatever you eat like to eat. So they do this experiment like going to work. So they put this time restricted feeding only 5 days a week, and the other 2 days you can eat whatever in the mice. Again, this purple light right here, effective, seems working. So that you can now try to see that only restricted the time feeding on a particular day, not every day you get the same effect. So very, very promising that. And since then, this kind of method become very, very popular in the human. And this is why a lot of the follow-up experiments was done in human. For example, this is a study done in America, if I remember, yes, right? Done in the 20 obese Americans. They already obese, get the problem of that. And then they ask them to select any time, but the time period is 10 hours. So you mean that from 8 a.m. to 8 p.m., whatever time you can pick, then just that 10 hours you can eat. And then you see in here, after about 12 weeks, there is a reduction of body of 3 kilograms. That's statistically effective. Again, working that. More interesting is that this method is also works in the normal people. That in the normal people, in our studies that is published 2 years ago in the Chinese this time, they use a healthy Chinese. If we put the time restricted feeding 9 hours per day for that and last for 5 weeks, there is a drop of the body weight around 1.6 kilograms. That's after this. Very effective as well. But this experiment tells you another interesting point is the time that you selected for taking the food is important to whether this method works or not. Because they put this experiment into 2 groups. One is called the early time restricted feeding. So that means that you can take the food from 6 a.m. to 3 p.m. day and compare another group that will take the food between 11 a.m. to 8 p.m. day. You see that this, we call this midday time restricted feeding. Their body weight drop as well as the fat drop is not as effective as that in early day. So that means that you need, if you wanted to eat, you better to eat it earlier, not in the midday after that. Very, very interesting findings of that. So we know that it works, but how does it work? And sadly, till today, right moment, what we know is that we don't know how it works, but we know that it works. That no reason, the mechanisms is unknown. At least we know that it is not related to your number of food you intake. That because in the experiment they done again in the mice in here, you see that this is the all you can eat mice. And in that time of the day you can eat it. This is time restricted feeding. If you calculate the amount of the calorie in every day they take, similar. That no matter you put the mice into a normal or fatty stuff. So the amount of food you take in using this method is the same as the one not taking it, not related to the reductions of the food. But we know that perhaps it is somehow to change the protein content in your body. Because if you measure the brown fat in your body, in the mice body, taking the high fat, the time restricted feeding, this is the control, the taking all you can eat mice in here. This is the time restricted feeding mice, and this is the different time of the day. And you see that they have more expressions of the gene. That means that the protein generations pattern is changed. Somehow it's changed. But what causes this change of it, we don't know. Still unknown or not. So a lot of things that we can do in this to find out that how it works and whether we have some more improvement in this. So at the end, I would like to conclude this is that obesity is really a health problem along all the way in everywhere in the world. And this kind of obesity is caused by multiple factors. The thing you eat, the environment, the medications, the genetics, all this work together and causes the problem. And it is very difficult to isolate which one is the most important one for doing that. And this overeating is a problem, but we don't know much about this problem. What we know is that a lot of the brain areas involved in it. And this is why we do not have a very effective medications, the drug, targeting the food intake so that would not cause us any side effects. No, we do not have this kind of drug. But whatever it is, if you wanted to control your body weight, remember the basic principle, energy metabolism. If you wanted to have your body weight drop, you better to increase your energy expenditure. At the meantime, reduce your food intake so that these two work together will give you the best outcome to lose your body weight. So at the end, I would like to thank my research team for helping us to do the experiment, as well as the support from the University of Hong Kong as an other agency in the Hong Kong, given financially to support our research work. And that's it for my talk, and thank you very much. And we are happy to take any questions about talk content. Thank you.